Thanks, Tonya, for joining as well. What I was just saying that I'll make a start in order to be mindful of your time and in order to get through materials. If there's at any stage questions you want to ask outside the recording, I can just post the recording or we can do them afterwards. But I just really don't want to keep any of you from other stuff that you've got lined up for today. What I'm gonna do, I'm just gonna jump to the objectives. So it just seems to be getting busier, the listing there, but there's not more to do than normal week. So I just want to mention a couple of words reminding about the exam and practical 3, a few words about exam 2 and practical 2, and then we'll focus on this week's module. This week's module is really gonna be more anatomy emphasized. There's a lot of anatomy that we go through, but I actually think it's easier because it's just structures to know. And another thing that I want to mention, a couple of words, there's 2 labs this week, so just make sure that you get a chance to do both of those. All other things, with the exception of the finals project, are things that we have already talked before, so I'm just gonna jump forward. Just a reminder that exam 3 and practical 3, I think they're open till 22nd, if my math works correctly. So end of this week. So if you haven't had a chance to do those, I encourage you to do so. But as well, like I've always said, if you end up pushed for time or need extra time, all you have to do is let me know, and I'll work with you. But I really recommend those. Exams and practicals carry a lot of points, so getting those. And I think that we had for the week 10 and week 11, I want to say, for those assignments, they were extended till today. But if someone needs more time, I'm happy to extend them even to the end of this week. But let me know if that applies to you. Probably since you're here, best that you either type on chat or give me a shout out now or later on, and I'll get it done automatically as soon as possible, or drop me the message through the Canvas messaging system. But it's just really important for me, since you're here, your needs get addressed. There's nothing new about the exam 3. It's the same as we've done before. Open book, no proctoring, 3 chapters, emphasis on respiratory and urinary, lesser of an emphasis on the water, electrolyte, and pH balance. But there's questions of both. On urinary system, the big emphasis is on the nephron. But I think we've talked about those already before. If you have questions, you can just let me know. One kind of, if you have not, I didn't get a chance to check, did you two already do yours? But if you have not had a chance to do it, I don't think there was an extra credit question this time, simply because I ran out of time to come up with one. But if it looks like that, then I'll put an extra credit question to the end of the course, that if that's needed. So we'll have a look at that. In terms of the exam 2 and practical 2, exam 2 is mostly graded. There's few missing ones, and I think that it's the ones at the end of the alphabet. But if you don't have your commented exam 2 yet, it's going to be there in next hour after this session ends. I'm literally just rechecking for the last time that everything's graded to the same level of toughness. Practical 2, I still need to check. There were a couple of things that someone else, another instructor, brought up. I just want to make sure that everyone in this class is getting every point that they need. But I will be posting an announcement of those if once both are up and ready, and it should be really, really soon, probably by the end of the day. There were a couple of points that I noticed, and again, it's kind of more of a thing that I just wanna, if you're reviewing your exam, you'll find them, but if you want some general kind of comments, I think that I always encourage answer something. If it's a multiple choice question, usually there's 4 options. You have 25% chance of getting it right. So by pure chance, answer something. If it's a true false, you have 50-50 chance. And I do think that the system grades those exams, same as practicals, really, really harsh. So if you have a question where there's multiple answers and you miss one of those and you pick one answer that wasn't the right answer, it really penalizes you with so many points that I think it's unfair. So that's why I want to go through every student's every question. I think I go through them 3 or 4 times. So just if your grade hasn't gotten changed, or if there isn't comments from me or general comments, there's always a general comment for every student individually, and usually with each question, especially if you got something wrong. Wait and you will see those, and only once I've commented on your exam, only once then the scores are representative of what it actually should be. Usually students move up approximately 1 letter grade, but that kind of varies a little bit. I do know that on this exam too, few students ran out of time. And again, I get it. We all have good days, we have bad days, or there might be technology, there might be anything. So if you feel after an exam that, darn, it didn't go quite my way, you can let me know and I can reset it for you as well. So then you attempt it again. But I think that there's nothing kind of a new out of those. Like I said, if you don't have the feedbacks yet on exam 2, it should be in about 2 hours from now available for you. There was one more point that I was meaning to say, and when I started making the slides, I forgot what it was. But I'll mention that on the announcement that I sent to the entire class. This week's assignments, I'll talk about them soon, but I did want to mention about the critical thinking question from last week. There were some issues that some students had, and I'll have to tackle those, and I will get back to you real soon about that. But thank you for doing those. It's more for the college than it is for this course, in terms of that we have that critical thinking question on every course. But since it counts towards your grades, I want to make sure that every student gets the chance to get the maximum points, and there's no technological issues and stuff. So if that didn't seem quite right, give me a while and I'll get back to you and we'll figure out what was up on that. But critical thinking scores are not yet up, so bear with me. For this week, really, there's not anything hugely new. We do the Learn Smart, which was 100% if you just complete it completely in terms of the points. Basically reading the textbook and answering questions. Then there's the quiz, and then there's the anatomy practical. And this time there's 2 labs. So I just wanted to mention, in case someone overlooks that, just make sure you get both of those done. And I think that they were both done through the McGraw-Hill website. So there shouldn't be anything too much of a curveball with those. We'll have a look of the key points for the digestive system. And let me just jump to another. Oh, I didn't mean to do that. And I'll open the slides that I wanted to share with you. And these slides don't look like the slides that we normally use, so don't worry about that. The lecture video that I should be posting by the end of the day should be on your slide format, so the chapter numbers might be wrong and the colors are a little different from what you should normally see. So if you don't see the PowerPoint, let me know. Okay, I will lab practical true. I think I saw that email and I was investigating it, but I haven't addressed it. If you can stay after this, let's get it sorted immediately after this session. If you cannot stay, I will still look into it and I will message you right after this. So we'll figure it out one way or another. Thank you for letting me know. I'm sure you guys have a lot going on. And last thing I want you to do is waste time on technology issues. So I'm just making a note for myself. But if you have to go to another meeting before we get to that, I will send you a message individually. But if you can stick around, we'll get that done then. But kind of jumping to this week's chapter, I really think that you will find that it is easier than the chapters, any of the chapters we've done so far. Because really, this is all things that you can, like pretty much for most of it. There's few minor things that don't apply. But all things that you can see concretely, they're physical, things that we can tactile, touch, we can see, we can actually identify with naked eye. So there's very little of this abstract stuff. And digestive system is so relevant to us all. So I think that that really is something that you have a working model with you that helps you think through it. And I recall that there were few students who were thinking of going to fields where we're especially focusing on the oral anatomy and so on. So I actually did work for the dental school in another country, and I do think that I'm very passionate about that part of the digestive tract. So we'll spend a little time exploring that. So if that's something that you're into, this is going to be a heavy emphasis on the first part of the digestive tract. Really, if we think of what's the function of the digestive tract, it's all about not just getting food in, but manipulating it and also taking what we need to get out of the food and then eliminating what's not needed. So there's more steps, I think, than we often think. And on this first kind of a video that you would have on the lecture videos, we really focus on a couple of general concepts and the oral anatomy. So those are going to be important for us to be familiar with. And really two terms that I want us to be familiar with, and I'm just trying to find a way to write, because I don't think they're written on this one, are going to be digestion and absorption. We want to be certain about what's the similar and what's the different between those two. So digestion is all about really breaking the food into smaller molecules. So that's the process of manipulating what we've taken in and getting it kind of chunked into manageable bits, whereas absorption is the stage where we move these small molecules into the body. And what do you mean it's in, or you might wonder, what do I mean that it's in the body when I've eaten it? Really, digestive tract is a closed tube that starts from the mouth, ends to the other end, and food that goes in there hasn't really yet crossed that membrane, so it would be inside the body. Yes, it's physically inside the body, but it has an opening that's still sealing the rest of the body from having it actually passed in as such over the membranes. So absorption refers to that stage where we're actually crossing that membrane, and these molecules become part of the body, whether it's to the blood, to the circulatory system, or whether it's to the interstitial space, or whether it's to the lymphatic system in case of large fat molecules. So digestion is all about just breaking the food into small pieces, and absorption is then having those small pieces crossing the membrane so that they're actually physically inside your body, past the membranes that separate the outside and inside. Those are the two big things that I do want you to be familiar in terms of the terms, and I think that they are really, really important for all of us to be comfortable with. really, this is just tying into what we've seen before, and we've already talked about it, so I won't make you feel miserable and show this time and time again. It's really just trying to highlight that systems are linked. None of these systems work by themselves. There's always connections. And really what we are looking on this chapter is going to be this part where we're looking of breaking sugars with oxygen into energy. And as a byproduct, we're left with the carbon dioxide and water. And we've looked at how to get rid of those with the respiratory system and with the urinary system. So in a way, we're kind of going in a reverse order, that we're focusing now on what starts all of this on this chapter. And some schools do go through this in a little bit of a different order, but I actually think it makes sense what your textbook and your school prefers to do, that we tie in the respiratory system and urinary system, because there's so much connections there. But just in case if you are really one of those learners who wants to go in order, we're kind of jumping backwards. But don't let that throw you off. So that's the formula. I'm not expecting you to memorize that formula by heart. If I were to ask anything about it, I would give you the components of it. But I have not thought about that far yet. We already talked about taking in the food, which was the part of digestion, and breaking the food into small, and absorption then when it crosses to the bloodstream. So I think that that's a good point to notice there. And you remember from our very basic reviews of basic concepts in introductory biology, when we break larger molecules into smaller components, we always release energy. So we're able to gain some energy. So this is essentially what your digestive system is doing and why it is doing what it is doing. And of course, then we have the process of getting rid of what's not needed while still preserving, for example, fluids, so we don't lose too much fluids. What I want to be... there they are, the two terms that I wanted to discuss with you. So digestion and absorption. I probably was jumping ahead of myself. So be familiar with the differences and similarities of processes. But the big thing with these are that digestion is just like I said, breaking the food into smaller molecules, whereas absorption is really that we're crossing that membrane. So those would be two things that I really, really do want you to be familiar with. There's two types of movements that I might have referred at least to the first one already earlier on this course, but these two movements are really the key movements that we end up finding in the digestive system. And again, it goes back to the same thing. If you learn something once, then you can, in anatomy and physiology, use that in other systems as well. So it is worth of taking the time to feel comfortable about those and learn those. And we're going to start by looking at the peristalsis. So peristalsis is this kind of a wave-like movement on a tube. And one way to think about it is that if you have a toothpaste tube here, there's two kinds of people, and you'll find that especially if you get into the relationships and so on. There's people who squeeze the toothpaste tube from the middle and they get their toothpaste. And then there's people who want to go from the very end and slowly move it to the end, to the top part where it comes out. And those people are highly irritated about people who squeeze it from the middle. So if you're kind of a person who likes to move it from the very end to the top, you would be doing a movement known as peristalsis. In peristalsis, we have muscle bands on this tube, muscular tube, that move in a synchronized manner so that they tighten so that they move the food forward on that tube. They start at one end, and once one part has constricted, part right next to it constricts, and one right next to it, and one right next to it. And you'll really see that material moves to one direction nicely. And whatever is behind is empty because we've squeezed it moving forward. So peristalsis serves the purpose of moving the food along the tract. And it does that with great success and great result. So that's the first one. There's the other type of people that I mentioned. And these were people who would squeeze their toothpaste more of considering that they do segmentation. In segmentation, okay, if you squeeze the toothpaste from the middle, some will come out initially. But if you keep doing that every day, every week, eventually nothing much will come out from the very end. So segmentation is a movement in the digestive system that doesn't even aim to really move the material along the tube. All it tries to do is mix and break down the food. So it really squeezes in one part only, and food might be moving back and forth. It might be getting squashed, but really the big goal there is not the movement. It's mixing and breaking the food that's inside the digestive tract. So those would be the two types of movement that I really, really do like you to, or would like you to get familiar with, so you can tell one from another, especially since we've not referred to the term peristalsis multiple times before. And that's going to be a term that if you go and continue your studies in the medical field, healthcare field, that gets used quite a lot. So digestive tract, just kind of to get us oriented, what it is. It's about 8 meters long, a continuous tube, and every now and then there's parts that are larger and there's parts that are smaller. There's walls that are thinner, there's walls that are thicker. But really, it's nothing else but a tube that starts from one end, empties to another end, and that's it. In addition to that digestive tract, we've got a bunch of organs that contribute to that process. So we've got our salivary glands, we've got our liver, gallbladder, pancreas. They all secrete stuff into that tube. But really, if you look at that tube is simply continuous loop. There's nothing of going back and then forth. It is, everything should be moving in one direction there and one direction only. If we start getting food or other secretions going backwards, that would be a concern and there would be issues. So really keep it simple and focus on the similar structures throughout the tube. And what's amazing to me, if we look at that tube, it doesn't matter at what part of the digestive tract we look at that tube, we always end up finding 4 similar layers in that tube. And these 4 layers are layers that we're going to have to learn. So if you're kind of hating the general stuff, I'm afraid that this is one of the general stuff that we have to learn. And we're going to go through these layers starting from the lumen. And I think that I've already discussed with you guys that lumen is always the center of the tube. But because I have had other classes where students didn't dare to ask that what is lumen, and they were all confused. So remember, we usually start when we discuss about layers, we start from inside and work our way up. So no matter at what part of the digestive tract you're looking, you normally end up finding these 4 layers. There's one part where you actually find one extra layer, but everywhere else, these 4 layers are present. So we're going to go through these, and kind of depending a little bit where you're studying, but most of the world, and especially here in America, you'll hear that these layers are described as being tunicas. Tunics or tunicas. So we have mucosal layer, submucosal layer, muscular layer, and serosal layer. And we're going to go through just really basic characteristics for each, but it is a good idea to know these basic characteristics. Let's start with mucosa. So this is the innermost layer, and I'm trying to get a laser pointer from here. This is the innermost layer of the digestive tract, the general model. And what you'll notice, even before we start verbally analyzing it, is that there's this wiggly part right inside. Well, we know whenever it's a wiggly part, it helps us to increase surface area. And we'll also notice that it's not super thick layer. This is the mucosal layer. So the function of mucosal layer is really to protect, to secrete, and absorb food. So it protects enough that if we eat some things, let's say that it would be very dry food, like eating dry cereal, and you swallow it down your throat, that dry cereal isn't going to scrape your esophagus before it reaches stomach, where we have various other liquids and fluids, that it's not going to damage the digestive tract. So it forms this protective layer. In addition, the mucosal layer has a lot of different kinds of glands, and these glands secrete various things into the food that's traveling through the digestive tract. And of course, in certain parts of the digestive system, we want to take in the material. So this was our absorption part. We want to absorb stuff, and it would be this thin layer of mucosa that would serve the purpose for that. And for that reason, we've tried to make sure that there's as much surface area as we possibly can make. Well, the next term, submucosa, kind of makes sense. It's below the mucosa if you translate it literally. And really what we find there, we find a lot of glands. So even though secretions might happen at mucosa, the glands might be located within the submucosa. So there might be a tube that carries the secretions from submucosa to the mucosal layer and then to the lumen. We also find a lot of blood vessels and nerves here. And really, these serve the purpose of regulating the digestion by having all of these rich supply of blood and nerves. So we want to know what's happening at different parts of different tubes. And if there's a lot of absorption going, well, we want to pick up the nutrients and the energy that's released, and we pick it up to the circulatory system. So it's the blood that picks up all this good stuff that we're able to absorb. So that's our submucosa. The next layer actually is made of two parts. We've got a muscular layer, and we've got all of this muscular layer is made of smooth muscle. And you might remember your smooth muscle from your general review of the muscle types. It's the muscle that we find especially in digestive tract, but also around the blood vessels. So it's mainly involuntary. We don't think that now I'm moving food from my stomach to my small intestines. It just happens. And there's two layers. The inner layer, this is a cross section, this section of a diagram that I've included here or drawn here. The inner layer is circular muscle bands. So they go around the tube. They're circle shaped because they go around, and when they constrict, they simply decrease or increase the diameter of the tube. The outer layer runs along the tube. So when they constrict, they actually pull the tube a little shorter or expand its length. So these are longitudinal muscle fibers that we find in the muscular layer as the outer layer. I said that there's one exception to this where we find a third kind of layer, and this is in the stomach. Stomach will also include oblique muscle fibers. So oblique were these ones that didn't align to any of our XY axes. They ran as something in between the two. They're not circular, they're not longitudinal. So that's when we'll talk about stomach later on, but the purpose of that is that we're able to do as many movements within the stomach. We're really able to mix that food there. So that's why we also have the oblique layer there. And the final layer that you'll see is kind of a thin one here, the outermost layer, that's our serosa, and that's made of connective tissue. And really the only function of that is to anchor these other layers and the digestive tract to where it should be. So those are the 4 layers that we find in pretty much all parts of the digestive system. So I would hope that you would feel kind of comfortable with those. So the next concept is a concept that I think that you might have heard before, especially when you went through the basic cavities of the body in BIO201. If you have not heard about it, don't worry, we'll go through it, but it's a structure known as peritoneum. So peritoneum is this serous membrane that really just aligns the abdominal cavity. It covers the abdominal cavity so that if we have, for example, infection somewhere else in the body, it doesn't spread to the abdominal cavity. Or if we have an infection in the abdominal cavity, it doesn't spread to other parts. In addition, it anchors all of the structures within the abdominal cavity to their place. It also does generate this concept that we've seen that we are generating always compartments within the body. So we've referred multiple times already during this course of something being in terms of their location, that is it, how does it relate to the peritoneum? It can be retroperitoneal, where it means that it's behind the peritoneum, or it can be intraperitoneal, or it can be subperitoneal, or whatever we end up finding. So that's the structure that we've been talking about all this time. And really, if you look here, we have a diagram cross-section of a body, and we're mainly focusing on the abdominal and pelvic region. So you'll see the front would be on this side, back would be on this side. We see our vertebral column. And we see a couple of big structures. We see liver, we see stomach, and we see some small and large intestines as well. Rectum coming here at the end. And at the front here, we see a female body. So there's going to be our female reproductive system. So you'll notice that the peritoneum lines and encloses all this abdominal pelvic cavity. And in addition, every now and then it goes into this cavity, forming these kind of loops where it anchors various structures there on its place. And one of these that's going to be important for us is going to be greater omentum. It's this loop that you see here. And when you do, if you get a chance to do dissections, like I really wish that we would have a chance, and if it wasn't the COVID time, I would probably try to take you for a visit to a place where we could do some. So if you start dissecting a human body and you remove on the abdominal cavity first the skin, then the fat, and then the muscle layer, once you get in there, you'll notice that there's going to be this kind of a serous membrane, connective tissue membrane layer that's really just nothing but a flap, this flap that you see here. And when you dissect, to really get into the organs that you want to see, you have to cut it off, or you have to flap it up so that it's out of your way. This structure, it contains a lot of fat cells, a lot of vasculature supply nerves as well. That's known as greater omentum. You remember the greater part tells that it's a significant, it's very visible, and omentum just refers to these kind of loop-like structures. So just something for us to be aware of if you end up doing actual dissections. I'm trying to think what else could I say about this. We've kind of already talked about visceral and parietal layers. In this case, they're just not going to be cardiac layers. They're going to be peritoneal layers. So we talk about peritoneal cavity, the cavity inside. neural control of the digestive tract. And again, this is probably largely things that you are familiar from your BIO201. There were two branches of the autonomic nervous system that we needed to know. And the one that's really important for us in terms of the digestive system is going to be the parasympathetic branch. So this was the one that was described sometimes as a rest and digest branch. So when you're resting and when you're digesting, you're not worried about getting attacked by an animal. You're not preparing to protect your life. You're simply letting the functions such as digestion and absorption to take place. Your urinary system is working harder. Your digestive system is working to get more energy and nutrients from whatever you have ingested. Your heart rate is slow. You're breathing deep and slow breaths. Your pupils get smaller. You're like you would have now. Let's think of there's Thanksgiving coming. After a Thanksgiving meal, most people have their parasympathetic system working really hard when you're just sitting on a chair or on a sofa and just processing all that food that you ate. The other branch was the sympathetic branch. And during that, when you're fighting for your survival, that was the fight or flight. When you're either thinking of running away or you're thinking of fighting the threat that you're facing. Digestion is not important. We just switch it almost off. It doesn't fully stop, but we don't put resources there. At that point, we're worried about staying alive. So then digestion is not going to be important. So I just want to remind you of those two branches so you're comfortable with those if you need to remind yourself of those. What we end up noticing is that there's a really rich blood supply to the digestive system and intestines. And most of the time, that's because this blood then picks up these nutrients and energy. And most of the time, all of this blood goes to the liver. And the reason for this is that your body is greedy. If you just give energy to your body, all other tissues, all other systems, it will just burn it off. It's not thinking about future. It's saying that, hey, I've got all this energy. Let's go crazy. And your liver is the place where the energy goes, or the nutrients and energy that we released from the food goes first with the blood, because that's the only sensible organ in this sense, that it actually stores this energy for later use. So just so you know that there's a lot of blood supply, but that's why liver receives so much, nearly all of this blood supply from the gut area, so that it can store this energy. So that's just to show that rich blood supply. It's not the best diagram, but it's the one that I could find here. So I guess that the question that I like to ask in exams as well sometimes is that where does the digestion start? And often my students tell me that, it starts at the mouth. And then I'm kind of thinking with them that, what happens in the mouth? Well, you secrete saliva. Do you really start secreting saliva when the food is in your mouth, or do you start secreting it earlier when you smell the food? And what happens is that we actually notice that a lot of the time it is the smell, or it can be even just the sight of the food that makes us salivate. And saliva contains a lot of digestive enzymes, such as salivary amylase that breaks down starches and so on. So digestion really starts even before food gets to your mouth. And why is the mouth such an important structure then? Why are we going to be spending so much time on our review of the digestive system on the mouth? Well, not only that's the structure where you're taking the food, just physically the passageway. That's where we screen that food. There's a lot of sensory receptors there. So we test, does it taste okay? Is the structure what we expect it to be? There's a connection to the nasal cavity, so we're also smelling it. So we're analyzing, is this something that we should actually swallow and put into our body? And of course, we talked about this in our chapter about respiratory system a little bit. This is also where speech So communication largely is involved in here. So we're manipulating the vocal sounds or the sounds coming from the vocal cords. So for communication, also an important organ. Sometimes you might see the mouth cavity being referred as oral cavity. I think that that's a term that you're already familiar. You can also see it being referred as buccal cavity. That's buccal. So that's another term that you can see sometimes. So just don't let that throw you off if that's being used sometimes. So either oral or buccal. So both of those terms can be used to describe the mouth cavity. What else should we discuss? I think we should just jump in to talk about the mouth. So, there those two terms were already. And let's define the borders of the mouth. I think that it's always useful to think, where does a structure start? Where does it end? So let's look at every direction and define what are the borders of the mouth. So anteriorly, your mouth, your oral cavity is closed by the lips. So at the front, it's the lips that stop the food from falling out, for example. How about laterally? Well, it's really your cheeks that prevent the food from falling out on a lateral side. So that's the boundary on a lateral side of your mouth, on the sides. Superiorly, you've got your soft and hard palate. And I'm trying to get the pointer again for myself. And you remembered that you had the hard palate at the front, at the anterior part, and soft palate at the posterior part. And hard palate is hard because there's bone inside, separating the oral and nasal cavity. And soft palate just doesn't have that bone, and eventually it will turn into uvula. So that's the superior, the top boundary of the mouth. Inferiorly, it's actually tongue that forms most of the floor of the mouth. And if you look, tongue is really it's actually a group of muscles. It's a huge structure. It takes way more space than we end up typically thinking in the mouth. And that's because it has so many important functions. It really can do amazing amount of movements for something that's muscular. I don't know if any of you have ever, I know that I come from a little bit of a different culture where every part of an animal gets eaten. So eating tongue, what kind of food tongue is usually very, very meaty, very fleshy, because it is just mainly muscle. So cow tongues, for example, you can see, I think even here when you go to the meat section, especially if there's butchery in the store. So something to keep an eye when you go shopping. Relating to this course. How about posteriorly? It's the oropharynx. We talked about that when we talked about the respiratory system. That's the back boundary of the oral cavity or buccal cavity, if you wish. There's another term that I want to discuss with you that we sometimes see being used, and that's the vestibule. Vestibule refers, if you turn that or translate that term from Latin, it actually means a chamber. So it refers to this space between the teeth and lips. There's almost like a cavity on its own or a chamber on its own. So vestibule of the mouth refers to this space between the teeth and between the lips. There's a chamber, and this is our vestibule. So that's a term that you might sometimes see being used. I think it's a good term to know. I don't know, I haven't yet written the exam for this, but I could imagine myself asking. But we'll go through whatever I might ask in the review session when it's time for that. I want to say a couple of words about the tongue. We already noticed that that was the floor of the mouth. but it also is formed by multiple parts. It's not a single muscle, and there's very large range of these muscles that allow us to make all these movements. What I want to highlight there are certain structures that we should be familiar with. So you'll notice all of these small rounded projections, dots, these are known as papillae of the tongue. So they can be smaller, as we see here at the anterior part, or more posteriorly, more pronounced. So this is the tongue, this would be anterior side, this would be posterior side. We're looking from top down. I'm trying to think if there's anything else in terms of the terminology of the tongue. Underneath the tongue, you'll notice this small fold or a ridge that connects the body of the tongue to the rest of the oral cavity, especially to the teeth and gums of the anterior part inside. This is known as frenulum. Frenulum is small fold, small ridge, and you'll actually find frenulum not only underneath the tongue, so there's many different kinds of frenulums. You don't need to learn what kinds they are. You just need to know the general term for this kind of a band is frenulum. You find one underneath the tongue, and if you look your own or you look your friend, it's usually fairly pronounced. You'll actually find one also here within our vestibular chamber, so after the teeth, or in front of the teeth, connecting them to the lip. There's usually another frenulum. Again, if you have a mirror, you can look yourself, or you can ask a friend to show you. It's up to what sort of relationship you have with your friends. Are they willing to show structures of their mouth for you? So this is the second place where we find a frenulum in mouth. There's a third place, and that's on the upper lip, connecting the upper teeth, especially at the front. There's a third frenulum there. It just didn't fit into my image here. So that's the term that's used there sometimes. And of course, a term that you have heard before is a uvula. That's the hanging projection at the very back, coming down from your palate, from your soft palate. Uvula, what would be its function? It really is a sensory organ. If you end up pointing or touching your uvula, you might get a gagging reflex. It kind of helps us to control that food doesn't go down too soon. Also, you remember it lifted up with the soft palate, sealing off the nasal cavity from the oral cavity. There's some interesting things that we could talk about in terms of the clinical relevance. If we look back to what we talked about the frenulums, sometimes if babies, for example, have trouble with latching, you might end up having those cuts. In terms of uvula, you can sometimes see something like this. This is bifid uvula. This is not that common, but you end up seeing those if you look enough to people's mouths. So it's divided in two, and this is more of a developmental problem most of the time, and it's a sign of individuals who might have some lesser pronounced issues with the development of the fusing of the two parts or parts of the base, parts of the head part of the body during the embryonic and fetal development. But just as a curiosity, look to people's mouth, you'll see interesting things. Next thing that I want to speak about with you is about saliva, and especially about the salivary glands. But just kind of before that, you know that saliva has many purposes. It included the salivary amylase, which started to already break down components of the food early on. So that's involved with the starch breakdown. So we start processing the food almost already before the food gets into the mouth. Of course, if you've eaten anything that's dry, you'll notice that saliva helps us to swallow stuff as well. So it makes the food actually turn into something that we now call bolus. Once you have had food that's been broken down in your mouth, and it's mixed with liquids of saliva, we no longer talk about food, we talk about bolus. So it's a bolus that travels to the rest of the digestive tract. And you can think of many other functions, cleaning the mouth and so on and so on. Here's a diagram that I've drawn of 3 salivary glands that we need to know. Some of them you have on both sides, so don't let that throw you off. And let's start with the easiest one. We've got here parotid salivary gland. I'm just seeing if it here they are written. So parotid salivary gland, that's located next to the ear, above the masseter muscle when you revise the muscles. And it really has a duct that travels to the second upper molar and empties there. How I remember parotid gland, think of pirates. They have a parrot sitting on their shoulder most of the time, and the parrot is right where the parotid gland would be. So if that helps you to remember, use that. If that doesn't, I won't feel offended. And of course, you would have one on both sides. Parotid gland is also where your facial nerve 5 runs through. So if there's issues, surgery there, parotid gland surgery, you can have, for example, too much growth in the parotid gland. So cancerous growth, that would be risky because of the nerves running through. And you had one on both sides. So let's have a look at the submandibular salivary gland. And really the name tells us again where it is located. It's located actually not below the mandible, but medially to the mandible. If you look, there's no gland down here. It's actually inside the mandible. I wish I had a model here so I could show. So kind of in the middle, inside the mandible. It opens up right at the base of the tongue lingual frenulum. So you remember here we had look of that. So it would open up here. That's our submandibular tract, the submandibular ducts that open up here. And then we have our sublingual salivary gland. Again, the name tells where it's located, below the tongue. And it has many openings at the floor of the mouth, so a bunch of places where the secretions of that come out. I guess the next question for us to consider is how much saliva do you produce in a day? And I'm always shocked when I think of the amount. It's 1,500 milliliters, so 1.5 liters. That's a huge amount of saliva that we produce in a day. And of course, we swallow that saliva and that gets picked up back to the fluids. So kind of referring to what we were talking earlier in our last chapter, that doesn't get wasted. You don't end up excreting it from your body. It gets picked up back to the fluid. But it tells us that we salivate a lot. Salivary secretions can also be something that we either know as, and I'm trying to get a pen here. Bear with me. We can know these secretions as serous, or we can know them as mucus. I don't know why it doesn't let me write. So that's just a way to describe what type of secretion we have. So the serous secretions are very watery, very liquid-like. And we end up finding that it's our parotid gland that makes the serous secretions. It's very watery secretion that comes out of the parotid gland. So we describe it as serous secretion. Where do we find our mucus secretion? It's the sublingual salivary gland that secretes mucus secretion. This is thicker, like we think of mucus that you might, for example, end up blowing out of your nose. It's kind of a thicker, stickier kind of a secretion. And then we, of course, have the submandibular gland, which actually does something in between these two. So it's a mixture of serous and mucus secretions. So in terms of the exam, I could ask that what kind of secretion does parotid gland do? And then you would know that it's serous. What kind of secretion does submandibular do? It's a mixture of serous and mucus. So that would be kind of a nice question. But do you remember the main point about the salivary glands? It is the salivary amylase that we secrete that is a component of the saliva, and that contributed to the breakdown of starch. What else can we tell? Let's look at the teeth of the mouse. So, of course, we know that teeth are some of the hardest structures in the body, and we get two sets of these. We get the primary teeth, there's 20 of those. You might hear these as milk teeth. That's the term that we use in my part of the world, or I think I've heard being used baby teeth. So these are the initial teeth that come, and early on in life, between 6 months, 2 years, that's when the primary teeth start to come. Can be pretty painful initially for the newborn to deal with. And eventually they get replaced by secondary teeth. So these are our permanent teeth, and there's 32 of those. And again, when you move from primary teeth to the permanent teeth, somewhere between 6th and 12th year of your age, of your life, that can be a fairly painful process. So I don't think we always give enough credit to the kids that how much they deal with. That's not super easy. Of course, kids get happy. We try to make them approach that a little bit better by stories of tooth fairies and so on. Why do we actually have, before we go into the different kinds of teeth and have a look of them, why do we have two sets of teeth? Why don't we just have the primary teeth? Well, earlier on during evolution, we actually lost our teeth fairly early. They got damaged, or they could just we physically lost them. But now that we're taking better care, our life expectancy is longer, we really get the second set of teeth before we actually need to get rid of the first set of teeth. So that's the reason why we're still dealing with those. If you're going into the dental field, I would say a good choice, because people live longer than ever before, but you still get only one set of the secondary teeth. So issues with teeth are going to be more and more and more common. So that's really, if you're thinking of where the business is going to be, if you want to be strategic, that's probably a good field to go into, because that's where the jobs are going to be available always, as people live longer. Other field, if you want to think of where you can combine your interest in A&P and have a job, funeral directors, embalming fields. People are always going to die, whether it's a good economy or bad economy. Maybe I'm too pragmatic. I think of things like that. But let's have a look at the teeth. How do you learn different teeth and what these are? Well, the easiest way to think about these is by dividing mouth into 4 sections, because that way you only have to learn 1/4 of the mouth, and then you just copy it as a mirror image, either sideways or up and down, to know what other teeth you have elsewhere. So only learn 1/3 of the mouth, and then use that to guide you for the rest. And let's go through what kind of teeth we have. We have incisors. So incisors are these 2 teeth right at the very front, kind of sometimes I hear people using like rabbit teeth. You've got 2 in 1/4 of the mouth. What incisors are especially well adapted? Think of things like biting into an apple. They're ideal for cutting in somewhere. They're not really about grinding type. They're not really about tearing type. They're kind of a flat and sharp biting into stuff. That's our incisors. The next ones that we're going to have a look are going to be our canines. So canines, we've got one moving further back, and they're ideal, if you think, for tearing stuff, such as tearing meat. A lot of us have fairly pronounced ones. I at least have a very sharp one. You notice a lot of the time in Hollywood, a lot of the time in aesthetical field, people might have their canines kind of sanded down a little bit. So they're not as sharp and not as pronounced as we normally end up finding in people. I don't know, it's just superficial stuff. Kind of a more of look like vampire. Then we get our premolars. So two of those. They're really kind of somewhere in between when we transition from incisors and canines to the molars. So they're fairly good for grinding, but not ideal for two of those. And then at the very back, we've got our molars. And molars are ideal for grinding different kinds of foods. So if you have to, for example, having a nut that you really grind in your mouth, you break it down. They're ideally adapted in terms of the shape for that function. So those are our teeth. If you go to the dental field, it's really weird. Initially when you go to dentist, you'll hear them talking to their assistant, saying all these weird kind of codes about teeth. What they're talking is which teeth it is and which aspect. Is it front, back, or just a flat aspect facing to the middle of the mouth? So you learn those, and it's really weird actually to be at the dentist. The visit is never the same when you actually know what they're talking about. Let's look at the tooth in a greater detail. A single tooth consists of two portions. So we have our crown, which is all this part above the gum line. And then we've got the root of the teeth, which is the below the gum. And let's have a look at what we find first in the crown. We find our enamel, which is one of the hardest substances that we find in the human body. Underneath that, we've got the dentin, which is more of like the bulk part of the teeth. And finally, we end up finding the central cavity, which includes blood vessels, nerves, connective tissue. So for you to get a tooth pain because you've got a cavity in the tooth, it has to normally travel quite far close to the central cavity so that the nerves there are affected. If you get a root canal done, we actually go to the central cavity and kill the nerves in there. So that's why you've got that long spike that you secrete stuff from, killing these nerves. Let's have a look at then the root. You've got a layer of cementum, which really does what the name suggests. It's like cement. It really anchors it fairly well, fills in the gap. And then you've got your periodontal ligament, which is even better in anchoring function, that the tooth stays within the root, within the jawbone, on the socket that it has there. I have some good stories about dental students who broke, for example, the needle when they were doing root canal into the central cavity of a tooth. And there's really little you can do to remove it from there if it's broken here, other than removing the entire teeth. So there's all sorts of things that can happen. That's why dentists need to have good insurances. Let's leave it to that. I think that the next thing, now that we've finished the mouth, we should continue further. And we're going to look at the rest of the digestive tract a little bit faster. So the first part is going to be, of course, our pharynx. So we have the nasopharynx, which dealt with only the air. But for the digestive system, we're going to be focusing on the oropharynx and laryngopharynx. But this is where both food and air travel, so it's kind of a shared parts. Let's look at then esophagus. In British spelling, there would be O in front, so that's why it might sound weird to you. I try to Americanize myself, but I keep forgetting. So what it is, it's just a muscular tube. It doesn't do really anything. It just carries the food. There's no real absorption or digestion going on. It simply carries food from mouth to stomach. So transportation is only proper function. When there's no food, esophagus is collapsed, kind of shranked, and it only widens when the food travels through. This is so that we have space for the trachea to always stay open. So we always want to have the airway secured. It's about 25 centimeters in length, not a super long one. Remember, we talk now about the bolus. We no longer talk about food. So I should probably change that in my slide. When you mix the food with saliva, breaking it apart mechanically and form into a ball, it becomes this bolus, B-O-L-U-S. And that's an important term to know. Let's have a look of the esophagus. What else it has? Well, it only just has the function of transporting food. You can actually drink, you can eat while standing on your head. It will still form that peristalsis wave that transports the food down the esophagus. It's not just the gravity, it's this muscle movement that moves the food. That's why you can eat, you can drink while you're standing on your head, you can do it in space, so you can try it out if you're bored. It will work. What else should we see? Oh, that's the word that I started with earlier. Here's a microscopic image of the esophagus. And what's interesting to me is that we end up seeing these very same layers that we talked before. We end up seeing our mucosal layer. The function of that was the protection and also the passage of materials. But in case of the esophagus, notice that esophagus does not allow any passage of the materials because this was just a transportation tube. So that's the exception that applies here. We'll also see our submucosal layer, this kind of a more bluish than purplish layer. Then we see our muscular layer, 2 layers of that generated this peristalsis wave-like movement. And what else? Then we should have serosal layer. We can talk about adventitia also. That's another term that's being used there. So that's probably more commonly used term for esophagus layer, the outermost layer. Next thing that I want to introduce you is the term deglutition. Deglutition is simply a fancy term for the process of swallowing. And what happens in swallowing, you can study it yourself. It's not actually just one thing, it's multiple phases that take place. First, your palate, soft palate and uvula climb up, they seal off the nasal cavity, your epiglottis flap opens, so you're able to swallow the food, and your throat kind of jumps up to catch the bolus, and then it just travels down the esophagus with the peristalsis. Is it voluntary or involuntary to swallow? That's a good question. Well, the first part of the deglutition process is voluntary, but once swallowing has started, you cannot stop. Rest of it is involuntary. So it's a mixture of two. The initial part you have control over, the second part you have no control over. The next part that we need to look at is our stomach. I'm just checking on the time if you're wondering when I'm looking to the side. It's this J-shaped structure, about 25, 30 centimeters in size, just below the diaphragm, mainly at the upper left part of your abdominal cavity. So it fills more of the left side of your abdominal space. Within the stomach, food now gets mixed with the stomach acids and other secretions. So we no longer talk about bolus. Now we talk about chyme. So we started with food, which turned into bolus once it was mixed with saliva and mechanically broken down and formed into nice ball. And once it reaches the stomach, we no longer talk about bolus, we talk about chyme. Chyme is more liquid than bolus. It's kind of at this liquidy mess, if you wish. If you've ever thrown up, you'll see it's a mixture of a lot of things. There's a couple of other things that I want to mention. Of course, your stomach is very stretchy, so you can change the size of it depending on how much material is there. Stomach also can be trained. So if you eat big meals all the time, your stomach will physically grow. If you only eat very little, you can't go on, if you've eaten very small meals for a long time, to having a huge meal because your stomach has physically shrank in size. So you need to kind of follow that. You end up finding structures called rugae. These are little folds inside the stomach. So this is to allow this expansion and shrinking as needed. But there's two parts of the stomach that I want you to know. And let's go through those. And let's start with the term cardia. Cardia is this part here. Don't think of this part. It's this part right after the esophagus, which is the green, has joined the stomach. So it's like the heart of the stomach. It's the initial part where the food comes from the esophagus. That's our cardia of the stomach. The next part is fundus. And if you look, fundus is actually above where the esophagus joins. So it's the part above that. And this is where most of the gases, most of the air ends up building if you end up having air in your stomach. So when we are taking medical images, we often see air at the fundus of the stomach. So that's why it's an important term for you to know. You might end up seeing that. Most of the stomach is made of the body, like the name suggests, and the very distal part is made by the pylorus. Pylorus can be further divided into pyloric antrum and pyloric canal. But if you know pylorus, I'm going to be quite happy with it. And after that, we've got our small intestines, and we'll talk about those separately. What else could we add to this diagram? We could add some sphincters. These sphincters are muscle bands that open and close these tubes. So we have something known as lower esophageal sphincter, closing the esophagus, the very end of it, and where the cardia of the stomach is. So we're closing that stomach acids cannot climb up to your esophagus. So the function of this really is to prevent the backflow of the stomach acids. What happens if you get stomach acids climbing up to your esophagus? We've all probably experienced that, the heartburn. So it's the stomach acid irritating the esophagus. What can cause it? Excess food, drink, obesity, pregnancy, running, things like that. But if you have prolonged cases of stomach acids climbing to the esophagus, you have heartburn all the time, you want to attend to that. Because if it doesn't get treated, if you don't take something to stop it from happening, you might end up with esophageal ulcers. And if you have ulcers that get irritated all the time, that increases your risk of developing a cancer at this site. So just we want that to work. What we end up finding, though, is that the lower esophageal sphincter is normally more of a physiological than an anatomical sphincter. We probably won't find actually muscle bands there. It's just something that works, but we don't really, it's hard to identify. That's the heartburn that we were talking. And there's those ulcers that I mentioned. I do want to mention really quickly a term. I don't know if you've heard before about hernias. What is a hernia? Well, let me take a color that's more consistent. So hernia is a term we use when something sneaks out from where it shouldn't sneak out. So this is when the stomach actually penetrates through the diaphragm, which runs here, and stomach climbs to where this small hole for the esophagus is to go through. And there's many different kinds of hernias, and they can become an issue. But I think we're going to keep it at this level, at that. Just know the term hernia. You can have hernias elsewhere, but this is the one that relates here. The other sphincter that I've kind of opened up here as a picture is our pyloric sphincter. Pyloric sphincter separates the pylorus from small intestines. So that controls that when does the stomach empty and how much of its contents does it empty to the small intestines. If anyone has had ever the runs, that's when the pyloric sphincter wouldn't really work, or everything just comes out and goes quickly through the small intestines, large intestines. We just empty it all. To clear, it might be that there's something that shouldn't be in the stomach, there's irritation, we want to get rid of it. The other way to get rid of it would be throwing up through the esophagus. So pyloric sphincter is really important. That's actually an anatomical sphincter that we can find, controlling how much and how often the stomach contents get emptied to the following parts. There's two things that I want to highlight here, two more things. You've got a curvature both on the medial side and on the lateral side. So the smaller curvature on the medial side is known actually as lesser curvature, and the lateral side curvature is known as greater curvature. So again, terms when you're describing locations of the stomach, you might run into those. Lesser curvature, more medial, and more laterally, greater curvature. What else should we know? There's the hernia that I was going to start talking. You'll actually see diaphragm separates the abdominal pelvic cavity from thoracic cavity. It's the diaphragm is the seat of muscle that separated that. You remember breathing-wise, it would come down. There's only a couple of holes in diaphragm. There's one for esophagus, there's one for aorta, and then there's one for IVC, inferior vena cava. I think that those are the biggest openings that we have in the diaphragm. But when the stomach starts to leak through, sneak through where it shouldn't come, we end up with all sorts of issues. I talked about these folds or these layers of muscle layers of the stomach, and we saw that we always had the circular and the longitudinal layer. Circular was the more inner and longitudinal, more outer layer. But in case of stomach, we also add this oblique layer. You'll notice that the fibers run kind of not in either one of these directions. The other thing that we see here quite nicely on this diagram are these rugae that I mentioned earlier on, folds inside the stomach. And they again shrink and expand when there's no food in a long time. They're especially pronounced. And again, I feel a little sad that we're not meeting face to face. I always use either fetal pigs or even you can use rats. And you'll actually, when you remove the stomach as a student, you'll find these rugae inside. It can be sometimes a little bit of stinky surprise to cut into the stomach, depending on how long these animals have been embalmed. But just something to be aware of. Hopefully, we'll get back to the classes face to face. If not, I'm probably going to do a video about that. But I couldn't get it done for this class yet. So really the function of the oblique layer, like we discussed, was to give more distension and mixing for the stomach. That's the main function. There's a lot of secretions. This goes now to the physiology side of things from the stomach. So stomach is lined with simple columnar epithelium. but it also has something that is known as gastric pits. And I can't really see the picture. I've got another window on top of it. So gastric pits are these drops on the stomach walls. And then when you continue down there, you'll see that there's gastric glands at the bottom of these pits. And these make gastric juice. And you secrete it's a secretion that comes from the stomach wall. I'm just wanting to see what comes next. When you secrete that, it's going to be about 3 liters a day. So again, a lot of secretion from this wall. That we end up secreting from the stomach wall in a single day. This is going to look like there's a lot going on, but remember, you can use your notes, you can use your screenshots, whatever in the exam. This is purely physiology of the stomach secretions. So let's have a look what we can. I was trying to hide the screen that popped up, but what we have going on here. And we're going to review these secretions one by one and see the connections between them. And we'll start with pepsinogen. Pepsinogen is secretion from the chief cells of the stomach lining. But what pepsinogen is, it's not functional, it's infunctional still. And pepsinogen gets activated into pepsin gets activated, and once pepsinogen is activated into pepsin, and I don't know why I didn't, it gets activated by the hydrochloric acid. So hydrochloric acid is secreted from the parietal cells, and hydrochloric acid activates pepsinogen into pepsin, which serves the purpose of splitting proteins. So what breaks the proteins apart is going to be pepsin. Pepsin is in its inactive form, known as pepsinogen, and you need to get to the stomach before the protein splitting happens. It's the stomach acid, especially the hydrochloric acid, that activates pepsinogen into pepsin. So we already managed to cover 3 of them, noticing how they're linked. Then there's a couple of others that we need to know. Let's look at the gastric lipase. So gastric lipase splits fats, and it's secreted from the chief cells again, and it is the pH that makes it very weak. So it's the acidity of the stomach that keeps gastric lipase weak. It doesn't really function that well in the stomach, but once the chyme leaves the stomach and goes to the small intestines, it's no longer as acidic in the small intestines. And that's when the gastric lipase becomes really active, really efficient, when the pH has been neutralized once we leave the stomach. So really, the fats get broken only after stomach, whereas the proteins were broken within the stomach. What else we should have? Well, the good question is that why doesn't stomach wall get broken by the acidity within the stomach? That's because we've got mucus layer protecting the stomach wall, also protecting it physically if there's something that could scratch or damage the wall. That's secreted from the goblet cells and mucus glands. And the last one that I want to mention here is intrinsic factor. Intrinsic factor is needed in vitamin B12 absorption, secreted from the parietal cells. So that's a lot. And really, I think that to make a full understanding of that, we should be able to see experiments where we mix fatty foods with gastric lipase in an acidic mixture and then change the acidity to more neutral, how they physically start breaking the fats in the food. And these are all labs that I prefer to do with my students, but unfortunately we don't have the chance to do it over video. However, this is why you've got 2 labs virtual labs on these chapters. You get to see how these secretions actually work. So if it doesn't make sense now, just take a note of those. And you can then, during the lab, see how they all connect to each other. Stomach ulcers, if that's what happens when your stomach layer gets broken. There's many risks that come with it. You can damage the wall through inflammation or bleeding. There can be bacteria spreading then through an ulcer to the rest of the body. Certain drugs such as aspirin can cause ulcers. So you just want to be careful and mindful about that. I'll leave it to that. Let's look at the phases of the gastric secretion, the juices. This is something that I think that we're not going to spend too much time on this review session. There's first phase is when you just see, smell, taste the food. That's when you already start secreting some. That's more of a reflex. Within 3 to 4 hours, this is stimulated by the stomach wall distension. So when your stomach is actually stretched, nerve cells there stimulate that we start our gastric phase. Certain chemicals, if you have protein present in the stomach, also promote the gastric phase. Caffeine promotes gastric gastric phase as well. And if there's low acidity, that promotes that. Let's make more acids. So this all can work through the through gastrin to promote the acidity within the stomach. It can be inhibited by low pH, for example, between the meals when the stomach is empty. Our gastric phase is inhibited. It's not very active. And the final phase is then when the food leaves the stomach and goes to the intestines. So, for example, the movement within the small intestines, movement of chyme, that stimulates it. But then later on, it starts to get inhibited. For example, when the walls of the small intestines are stretched, when the acidity of the small intestines grows, when there's a lot of fatty content, that would slow down the intestinal phase. This is all to allow enough time for things to happen in intestines. So we want to have enough time, for example, for the fats to get digested. What else could we mention regarding that? I'm just looking for a note that I lost. I think that that's a pretty good summary of those. Just a sec. So that will probably become clearer once we review the lecture videos, but that's just this amount for your review session. Remember that the labs will clarify a lot of that, but these are just some to know. What I want to do next, I want to talk about, well, we've already had a look of this a little bit. Why doesn't stomach get absorbed? We already talked about the food facts. We talked about that there's this acidic environment. We act against that. We don't have that much villi. We have a lot of rugae, the folds, but they're not as small as the villi. We have the mucus layer. So really, the stomach does not allow for the food to cross that's been broken down to the body. This all happens at the small intestines. So stomach is really just for these chemical processes to start breaking down food. Start the digestion, whereas the absorption happens later on. So you remember that esophagus, there was no physiology really there. It was simply for the transportation of the food from the mouth to the stomach. And stomach ear didn't really allow for the materials to pass across. It's really within the small intestines where most of the absorption takes place. And as we finish this section, we just want to remind ourselves that we've already seen food. When you mix food with saliva, and that mechanically break down the food, that forms a nice little ball, we start talking about bolus. Once bolus reaches stomach and gets mixed with stomach acids, we start talking about chyme. This was the very liquid kind of a mixture that we have there. And then at the large intestines, we recover, take back those fluids from the chyme, so it becomes much drier. These are our feces. So I think that that should make sense. The last bits for us to look at are going to be our small intestines and large intestines. Small intestines started here within the pyloric sphincter where the stomach ended, and it actually ends up where the large intestines start at ileocecal opening. It's the main site of the nutrient absorption, like I mentioned earlier on, and it's made of 3 parts: duodenum, jejunum, and ileum. How do you remember this? That's a lot. Duodenum, jejunum, and ileum, I always try to come up with mnemonics. And for me, the best mnemonic about small intestines is DJ Ill. He plays really sick music. So just the first letters. That might help you to remember it. If it doesn't, I totally get it. So duodenum is the first part, about 25 centimeters long. It curves around our pancreas right after stomach. So that's the first part of our small intestines. After that, all this little sausage-like thin sausage that we see in the middle of the abdominal cavity is jejunum and ileum. And where does jejunum and ileum end, or jejunum end and ileum start? We cannot really tell. There's no actual transition point. The first part of it is jejunum, later part is ileum, but we can't really tell where one ends and where another starts. But they form the middle part of the abdominal cavity as the intestines. I'm thinking, is there anything else to say about this? If we look at the small intestines, that was the site where food got mainly absorbed. So we have a lot of these modifications that increase the surface area of the small intestines. So folds, villi, and microvilli. That allows us to make sure that we get a lot of area where the food, nutrients and energy can actually be absorbed. About the size of a tennis court when you lay it all out. So packed into very small space. So that's why these folds again become important. These secretions we've already kind of mentioned, I think, to a large amount. So you remember mucus was secreted by goblet cells. Peptidase breaks peptides into amino acids. Sucrase, maltase, lactase, they all break disaccharides into monosaccharides. Lipase breaks fats into fatty acids and glycerols. So there's a lot of secretions within the small intestines, and there's many hormones that can also act on this area. And that all is just telling us that this is a major site of absorption. Let's have a look at the large intestines. So small intestines end here and large intestines start. And this transition point is known as ileocecal sphincter. If you think of DJ ill, ileum was the last part of the small intestines, and first part of the large intestines is cecum. So this transition point is known as ileocecal sphincter. So we first have cecum here. From cecum, you can actually see appendix hanging out a lot of the times. What's the function of the appendix? Really not much these days. Back in the day, it was the evolutionary, or it is now evolutionary remain. Back in the day, that's where the bacteria for digesting plant-based diet was probably housed. That's still somewhat of a speculation. We haven't fully proven that. It can get inflamed and you can have your appendix removed. And then we get to there's an appendix actually in a surgery we're removing. Fairly nicely these days we can do a surgery that doesn't leave big incision scars on the external parts of the body. Then we get to the colon, and colon is really this major part that you see. And colon can be divided in two different parts. So first part, ascending colon, is the part that climbs on the right-hand side of your abdominal cavity, from bottom to up, kind of to the level where the liver is. Then transverse column crosses from right side to the left side. Descending column comes down on your left side. And finally, you've got sigmoid colon. And you remember sigmoid colon because it looks like an S letter a little bit. And finally, you've got your rectum that allows then for the feces to be passed out. There's a little bit of a better, more anatomically accurate picture. You'll notice large intestines are physically much larger. There's some fat nodules there. And if you've ever wondered the odor of the feces, it's really the ammonia sulfide, the bacteria that work within the large intestines. So what's the function of the large intestines? Since we know that small intestines was the main site of absorption, large intestines instead play main role in the fluid regulation that we just talked about in our previous chapter. So they play a significant role in water reabsorption. We take the water from this chyme away, and now we end up with feces, much drier. We also recover a lot of electrolytes. Anyone who has had constipation, that's when too much water gets taken away and we end up with more solid material than we want. Anyone who has had to have their large intestines emptied, for example, for colonoscopy, you drink a lot of liquids that contain, for example, magnesium, make your colon to empty so that there's nothing left. Large intestine is the major site where a lot of bacteria, flora lives, and positive, good bacteria for us that helps us to break down whatever is left there. You actually find some fermentation happening, and a lot of vitamins are synthesized here. And because it's so highly populated with intestinal flora, anything pathogenic really cannot enter there. All the space where the pathogens could enter has already been taken. So that's why some people prefer to do colon cleansing and things like that. Okay, that might be good, but if you do it too often, you might actually end up washing away the beneficial intestinal flora from there. So just something to bear in mind. And then we have the very last thing on this chapter to talk about the 3 accessory organs that we have to cover. We already talked about the salivary glands, but we focus on these accessory organs, our liver, gallbladder, and pancreas. And we'll go through those a little bit quicker. Liver is located within the upper right abdominal quadrant. If you studied the quadrants back in the day, below diaphragm takes significant amount of space from there. We remember a lot of blood supply to there from the intestines, and that was for the purposes of storing the energy. Otherwise, the body just goes crazy and burns that off. There's a lot of functions. One day, I think I tried to list them, and I got to about 100, and I gave up. But some of the most important functions that we have, the metabolic function, storing energy, also storing vitamins, storing glycogen. If you have dealt with issues with diabetes, Type 1, you might be familiar with that. Filtering blood also within the liver, and detoxification. So if, for example, if you go out on a night at the town and you're having fun time relaxing, your liver definitely isn't relaxing. It's filtering your blood and trying to remove as much alcohol as it can. The main function of the liver that I want you to know is the secretion of bile. And what does bile do? Bile leaves the liver and travels to your gallbladder, where it gets stored and concentrated. And we'll talk about that a little bit more later on. But bile is very important for digesting fats. So people who have had their gallbladder removed or whose liver doesn't produce bile, they often cannot eat really fatty foods. The fats don't get absorbed. In terms of the anatomy of the liver, there's some structures to study: the falciform ligament, round ligament. These all are in your full lecture video. Hepatic artery was the main vessel bringing the fluids there. In terms of the bile ducts, I've made a diagram here. I want you to know the common hepatic duct, which kind of collects the bile from the liver, brings it to this point, and from this point, it's the cystic duct that carries the bile to the gallbladder, and then when gallbladder empties through the cystic duct, it continues down the bile duct and empties to the small intestines. This structure here that you see is our pancreas, and we'll talk about that as the very last structure. Gallbladder, let's have a look at that. Gallbladder, its main function is storing and concentrating bile. It does not make bile. That's a good question in an exam, that what of these organs makes bile? And I often get people telling me that it's gallbladder that makes bile. That's not true. It's the liver that makes the bile. Gallbladder stores and concentrates the bile, makes it more potent. What sort of clinical relationship or clinical issues can we find here? We can sometimes have gallstones. Gallstones are when the cholesterol escapes the bile and crystallizes. So these little rocks, if you wish, within the gallbladder. They can be too big to get rid of them. We can use many different ways of dealing with them. Sound waves, or some just pass their gallstones. It kind of depends a little bit. But that's often a significant indication that there might be too much cholesterol present. And the last one that we needed to have a look was, of course, our pancreas, as I said. In terms of our pancreas was an interesting organ because it was both exocrine and endocrine organ, or exocrine and endocrine gland. So as an endocrine, it plays a role in the sugar regulation with the insulin and glucagon, whereas as an exocrine gland, it was all about making pancreatic juice. So we're focused on this chapter on its exocrine function. And pancreatic juice is actually the most complete digestive juice. That's the digestive secretion that really helps us with absorption of materials. So as you remember, it was within the small intestines where most of the absorption happened, and that's largely thanks to the pancreatic juice. Pancreatic juice neutralizes the acidic secretion from, or acidic mixture, acidic chyme leaving the stomach, and it also allows many enzymes to start working as we have now gotten to more neutral pH. So a lot more if they don't work, or at least they work more efficiently once they get to the small intestines. Because right at the small intestines, right at the duodenum, we dump there the pancreatic juice as an exocrine secretion from the pancreas. This opening that you'll notice, we used it also for the bile to come out, so for the hepatic system. So we call this opening actually hepatopancreatic ampulla because it serves the both functions. Let me see if I can find a pen. And you remember term ampulla was an opening of some. So it's this opening here, shared both by pancreas and your gallbladder secretion, or secretions from the gallbladder. I'm trying to think of if there's anything else that we should highlight. I don't think so. I think we've covered pretty well Oh, there's nicer diagram than what I showed here, and you can actually see this hepatopancreatic ampulla there. Let me take my laser pointer there. That really completes all I had as a review for our digestive system. As you remember, you will have all the material also as a full lecture or full story in your actual lecture videos. And I'm gonna close this part and jump back in to our review. Weekly session. And anyone who joined later, I'll show the rest of the important things that I wanted to mention about the weekly session. But I first want to wrap up this part. So like we discussed, we've gone through the digestive system. Like I mentioned earlier on, some students have had their Connect access code starting to expire. College says that you really should buy a new one. I will have alternative activities available, but I've really struggled to have them all ready. So bear with me and I will post those for anyone who needs an alternative activity. I recommend that you drop me a message though in Canvas just so that I can be mindful that I don't prepare activities for chapters that you don't need activities for. But there's always a way to get those points. You'll also notice that I've opened rest of the chapters for this semester as well. If you want to go ahead, you know that your Connect access code is about to expire. You can go and get these activities done before it expires if that's something that you want to do. If you're missing any assignments, message me and give me specific details which assignment it is, or you want to retake something. I'll definitely facilitate that. Finals project, I'll talk more about that I think next week, the details with all the grading sheet, because that's what you want to do. You want to see how you're going to be graded. That's a little bit next week, a little bit later, we'll talk about that. But it's going to be an independent project. It can be about a clinical condition that relates to what we've discussed or another topic that we covered, or highlighting how these systems are interacted. It can be a presentation, it can be an essay, it can be a poster, it can be anything you wish. A lot of students have preferred to do like posters on a PowerPoint, just to cover the details that you have to do. How this is going to be marked, it's with a grading sheet, grading matrix. So I'll give you the matrix ahead of the time so you know what I'm looking for and how many points mentioning each thing carries. This is also a chance to get a lot of extra credit. So I make sure that you have a chance. If you're not in a grade you want to be, you just invest a little bit more effort to the finals project and you'll do great. I don't want you to have to memorize stuff for the final exam. I don't want you to have to stress about that. So that's why we have this all as a project kind of a thing. There might be also an option to do an exam if you prefer rather than a project. But the goal is that it shouldn't really take too much of your time to do it during the finals week. I want you to be able to focus on other things as well. Tutoring services, I always mention about them. You have them through the college, but also I'm happy to help. And we've gone through everything I wanted. For anyone who didn't get the first part of this session, I'll just quickly jump right to the back to highlight what were important things to note. So you have this week, it will be extra credit, a lot of extra credit in the rubric. So I'll show that you can definitely earn those points if you're not where you want to be. My goal is that if you're aiming for a certain grade, you have a way of getting that grade. So trust me, there will be a chance to earn those. So what I do normally, it's that you get the extra credit through your final project. You just put a little bit more effort on that final project. If after that you still don't have the grade you want, then I can give another extra credit assignment. So the reason why I'm giving all this, or I'm trying to make the finals week lighter, is that I try to connect with all of you, at least through message, but I would like to speak face to face through web services with you, each one of you, that where your grade is, where you're standing, and if it is the grade that you're aiming for. If it's not the grade that you're aiming for, at that time we can have that dialogue and what do you need to do to get the grade you're after. Is it feasible? If you're at the D, it probably is going to be hard to get to an A, but it might be very possible to get to a C. It might be even possible to get to a B, and we'll have a look what you need to do. So that's why I try to make time for that on the finals week. But a reminder, the exam tree and lab practical tree, this week you still have that to finish. A lot of students have already done those. I don't think there's anything new, anything too unlike what you've seen before on those. Anyone who wasn't at the beginning, just a reminder, exam and practical too, they're mostly graded for the exam. There's few students who are missing. So if you don't see comments on your grade yet, you're one of, unfortunately, of those few that I still haven't finished. I'm trying to finish them within the next hour after this session or so. Practical too, there were some hiccups that another instructor noticed. I just want to make sure that you don't lose points for anything that you shouldn't lose. And again, once those are finished, I'll make an announcement that the practical 2 results are now the actual numbers. But most of the students for their exam 2 grades seem to climb up. This is just in general by 1 letter grade. I do think that the automated system grades it too hard. So a couple of points to notice: always make sure you answer something. There were some students who just didn't answer anything. You have a chance, at least by probability, getting a right answer, 1 in 4th probability. If it's a multiple choice question where I usually have 4 options. If it's true or false, you have 50-50 chance of getting points for that. So always at least guess. Like I said, the system grades this way too hard. I think that if you get, for example, out of 4 things that you have to pick in a question where there's multiple things to pick, you get 2 of them right, but 2 wrong, then you would get 0 points. And I think that that's unreasonably hard, how the system grades it automatically. So that's why I grade them manually. I go through every single question, every single answer you've given at least 3 or 4 times to make sure that you get points where I think it's reasonable that you get points. Some students ran out of time on the exam too. If you run out of time, do let me know, because I can reset your exam. Then you just take it again. Time management, really, I think it's really important on these. So if something doesn't go the way you want it and you feel really bummed out about your exam or your practical, it's always worthwhile to speak to me so we can see, should you retake the exam? Should you do something else? In terms of, there was something else that I was meaning to mention about the exam too, and I don't remember. So once I remember, I'll make an announcement. In terms of the critical thinking from last week, there were some issues with that. It's not graded yet. I will check that. Give me a second. I will check. Can I see all the grades? Someone was, it might have been you or it was someone else saying that it didn't show up the way it was meaning to show up. So let me check that. How the grades are showing up. But what I want to say is that with the critical thinking, I'm going to release the grades for that real soon. For this week's assignments, there's 2 labs. Just make sure you do both of those. And that's really the points that we covered before, if you didn't make it to the very early part of this session. I'm going to stop recording and I'll go through any questions that you have. So that we can go through them without them being on the record, because I don't want, if it's, for example, about your grades, to share that with the entire class. But in terms of that question that I think I already answered, but just to highlight that if there is, okay, thank you. I really appreciate you having sent the both through the critical thinking. I really think that it is a little bit of a an ideal way for us to post and grade it. But just what I was going to say earlier on, the extra credit assignments, extra credit ways of earning points towards your final grade, there will be plenty of extra credit available from the project that you will do. And if you still are not where you want to be, then we'll just talk and we'll figure out what do you need to do. It might be something else in addition to that, but I try that the project would be enough that you can earn extra credit, about 1 letter grade or so if you want. Then you just work a little harder on that project. We'll talk about the project next week. So I'm gonna check the labs for the critical thinking, electrolytes, and urinary system that you had questions, but I'm going to stop the recording if you don't have any questions that you want to share with the rest of the class. And let me stop that there.